Alright, let's solve the rational equality. 2 over x plus 5 is greater than 3x over x plus 10. So I'm just going to use a different color here. But so to do this rational equality, what we want to do here is let's move let's make one side equal to 0. So I'm going to move the 3x over x plus 10 to the other side. So you get minus 3x over x plus 10 is greater than 0. Okay, so you want to set one side equal to 0. That way you can look at the rational equality either being greater than 0 or less than 0. Now what we want to do here is make sure that the denominators are the same. So we need to find a lowest common denominator. So the lowest common denominator here is x plus 5 times x plus 10. Right, and if I multiply this one by x plus 10, because I want to match the... Okay, maybe I should use a dot here. So if I multiply this by x plus 10, you can have the same denominator. You can have this lowest common denominator. I'm going to multiply the 3x over x plus 10 by x plus 5 over x plus 5. So I'm just creating an equivalent fraction, right, with that denominator. So you basically get 2x plus 10 minus 3x times x plus 5. Remember, there is a negative in between them. And the common denominator, I'm just going to make this collective x plus 5 times x plus 10. Okay. Once I have that down, what I'm going to do is expand the numerator. You expand the numerator, you get 2x plus 20 minus, if I expand this guy, 3x squared minus 3x times 5, which is 15x. Okay, so I'm just going to collect the numerator really quickly before I actually place this on the denominator. But you can notice that you have a negative 3x squared, 2x minus 15x, so it's negative 13x, plus 20. Okay, so now that we have this down, right, and this is all over x plus 5 times x plus 10. And this, all of this is going to be greater than 0. Okay, so this is what we have. Now, using this guy, I want to see if I can factor this. All right, so if I look at the numerator, we have negative 3x squared minus 13x plus 20. And you can see that a here is negative 3, b here is negative 13, c here is 20, ac here is negative 60. You want two numbers that multiply to negative 60 that add up to negative 13, right? So we can try to postulate some values that can give us this, right? Okay, and you can notice that this quadratic expression is not factorable, right? So you'd have to actually utilize the quadratic formula. So I'm going to be using x is equal to negative b plus minus b squared minus 4ac over 2a. Okay, and by doing so, what I'm going to get here is x is equal to negative b, which is 13 plus minus b squared. It's negative 13 squared minus 4 times negative 3 times c, which is 20, right? And you're going to get 13 plus minus square root 169 plus 12 times 20, so 240, right? X is equal to, and then this whole thing here is divided by 2 times negative 3. This is over negative 6. Okay, my two solutions that I'm going to get here, x can be equal to negative 5.537 or 1.204, right? So this is something more of, I'm just rounding it off as an approximation. I'm going to use decimals in this case because it's just easier to see, right? And using these values, now what we need to do here is we have our critical values, right? So these are our x-intercepts, but we also need to understand that we also have our vertical asymptotes at negative 5 and negative 10. Okay, so these are our x-intercepts. Okay, and in this case, these are going to be our critical values. Where another set of critical values are also going to be our vertical asymptotes. Okay, so having said this, what we're going to do is we're going to plot all of this on a number line to figure out all of our intervals, right? So let's say that this is negative 10. I'm going to put the vertical asymptotes in an open circle. You can notice that because the expression itself is greater than 0, right? This is our simplified expression. Because it's greater than 0, we can understand that everything is going to be non-inclusive, right? So we're just going to use open circles for everything. So we're going to get negative 5 here. We're also going to get, negative 5.537, negative 5, right? I'm not drawing this to scale per se, right? And we'll also have 1.204, and this is positive infinity, and this is negative infinity. So this is somewhat unconventional because we don't have values that are going to give us exact values. We're going to have decimals and so forth, but it's good to kind of understand some of these exceptions to some of the more nicer numbers that usually we'll get in terms of values for your answers, right? So in this case, when you look at their intervals, so we have negative infinity and negative 10. This is one of our intervals. The other interval here is negative 10 and negative 5.537. The other interval here is negative 5.537 and negative 5. Interval here is negative 5 and 1.204. Another interval here is 1.204 and positive infinity. So make sure you look at all of these intervals. It's important, right? And next what we're going to do here is we're going to create a table of intervals to kind of solve for our inequality, right? So if we're doing this, I'm just going to create the table of intervals out here. Okay, so you want to put your intervals on top. Okay, and then this x belongs to, and we'll put down our intervals, so negative infinity and negative 10. Right, there's negative 10 and negative 5.537. Right, negative 5.537 and negative 5. Okay, so just make this a lot more clearer. Okay, so negative 5.537 and negative 5. Then we get negative 5 and 1.204. And 1.204 and positive infinity. Okay, so these are our intervals. And then let's place our factors. Well, one of these don't actually have a factor, but because we can understand that our x-intercepts are negative 5.537 and 1.27, what we could do is we could make an approximate factor just to make things a lot easier for us. So this is x plus 5.537. This is approximately x minus 1.204. Okay, once again, these are approximations, right? And we also have the denominator, so 1 over x plus 5. Right, we'll also have 1 over x plus 10, and we can call this the function collectively. Okay, so let's call this our rational function r of x. Okay, and we want to figure out which intervals will make this greater than 0. Okay, so let's start with the first interval, negative infinity and negative 10. So in this interval, I'm going to let x equal negative 11. So you can see that this is negative, right? Negative 11 minus 1.204, negative 11 plus 5, negative 6, a negative 11 plus 10, negative, and then this is positive. So this is one of our solutions, greater than 0, right? Let's figure out when x is equal to negative 6, right? So this is negative, negative, positive. Well, this is going to be negative, so this is less than 0. This is not one of our solutions. When x is equal to negative 5.25, right? This is positive, negative, negative, and positive. So this is actually positive. This is greater than 0. So this is another one of our solutions. There's two solutions already. Let's say x is equal to 0. So this is positive. This is negative. This is positive. This is positive, and this is negative. So this is less than 0. and then here x is equal to 2, so let's say it's positive. So you can pick any number within that interval. This is positive, 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 and then this is positive. So our solutions here, the intervals in question that are going to be giving us our answers, this is a positive interval, positive interval, positive interval. So we can say that therefore x can belong to negative infinity and negative 10, union negative 5.537 and negative 5, union 1.204 and positive infinity. Okay, so those are our three intervals that will satisfy this inequality.